our analysis. Already we started our unit number 2, that is the radiating elements and its analysis. Okay, so now radiation resistance E bar H bar, whatever the steps we have studied in last lecture, like infinitesimal half wave dipole, short wave dipole, is my screen is visible to all? I open the PowerPoint presentation.
No, ma'am.
Okay, so I want to share. Right, this is the analysis steps. Define the source, write the expression, find out the A bar, H bar, E bar, and then P bar. Okay, this is the analysis steps. Now students, whatever the derivations are there, suppose now we will start with infinitesimal dipole. Yes, please tell me what is the length of infinitesimal dipole. Hello, length of infinitesimal dipole.
Lambda by 50 less than.
Yeah, it is length L is less than lambda by 50. Lambda is the wavelength. Okay, whatever the wavelength it's creating divided by 50, तो वो length होगी dipole की. मतलब हम जो antenna as a dipole हम analysis कर रहे हैं, वो length is very small. Actually, it is infinitesimal small, right? In practical antennas, such a small antenna is not useful, but when we connect the small infinitesimal dipole antennas and then again integrate the result, then we can use such a type of small antennas. Okay, so for this infinitesimal antenna, okay, this is the diagram. Infinitesimal dipole, the length of the dipole is very small, then termed as an infinitesimal dipole or short dipole. Remember this name also. Infinitesimal is a short dipole. Hence, current is constant over its length. The dipole with constant current over the entire length is referred as a Hertzian dipole. In real life, such a very small length current element does not exist, but serves as a building block from the which field of the practical antenna can be calculated by means of integration. Okay. Now, suppose we want to draw the diagram analysis के लिए. So this is the antenna. It is placed. This length is along the z-axis. Okay, so length dl is equal to dz as it is placed on z-axis. Now here from this one point is B. Point B is there. Now see this dl by 2, dl by 2. Means at the center of this half portion is on upper side and second half is on, and this complete length is your lambda by 50. So this is the infinitesimal dipole. Now, what are the assumptions for this analytical treatment? Length is very small, dl is equal to lambda by 50. The radius of wire is very small compared to wavelength. Where is the radius? Small a. The radius of the wire here, that a is there. This is the complete diameter d. So radius of the wire It is very small compared to wavelength. So it's less than again. Then antenna considered to be thin dipole. Okay, these are the assumptions. The dipole is placed at origin symmetrically along the z-axis. The current is constant in z direction. Now, dipole is placed at a origin along the z. So this dl, current distribution I along z-axis is equal to I0 AZ bar. So where I0 is a constant current. Okay, the medium is a free space. यहाँ पे एक पॉइंट कंसीडर किया है, point B is x y z. Here is the origin point is x dash y z y dash and z dash. This is the point B is at a distance of r. Okay, up. This is the from x axis angle is created, that is the azimuth angle phi. अभी हमारा स्टेप 1 क्या है? व्हाट इज द स्टेप 1? कैलकुलेशन ऑफ ए बार. ठीक है, वेक्टर मैग्नेटिक पोटेंशियल. That a bar is equal to, I think formula a bar is equal to mu I upon 4 pi r. That is the general formula, mu I divided by 4 pi r. ठीक है, I think माझ्याकडे नोट्स मध्ये this is the B bar is equal to del cross A bar. This is the vector magnetic potential, and for this using A bar we have the formula A bar is equal to for line current mu 0 ideal bar divided by 4 pi r. For surface current mu 0 k ds divided by 4 pi r. ठीक है, this is the general formula for the magnetic vector potential A bar. Okay, हा लिहून ठेवा नोटबुकला. आता whatever this I is the current distribution along the your dipole length. So here to determine the magnetic vector potential A bar, consider the spherical coordinate system. Everywhere for the analysis we want to consider the spherical coordinate system. Okay, so this A bar x y z is equal to mu L, लेंथ से मल्टीप्लाई करना है, mu I dl divided by 4 pi. In general, vector potential is expressed. Now here whatever this I of x dash, y dash and z dash, this is indicating I at the origin. Here at this point, what is the current I? X dash, y dash, z dash. Okay, and e raised to minus jbr. This is the complex part of the equation where we are considering this beta, that is the phase constant, e raised to minus j beta r. हे इक्वेशन्स मध्ये घ्यावे लागतात. आता जसं युनिफॉर्म प्लेन वेव्हच्या इक्वेशन्स मध्ये आपण एक फेज साठीचा फॅक्टर ऍड करायचो, तसा इथे ह्याला ई ने मल्टिप्लाय करायचंय. आता इथं हे जे इक्वेशन्स दिलेले आहेत वेक्टर मॅग्नेटिक पोटेन्शियलचे, हे तुम्हाला लक्षात ठेवायचे. ठीक आहे, ए बार, व्हॉट इज द ए बार फॉर दिस इनफायनायटेसिमल डायपोल, तो कसा लिहायचा आहे. नंतरून वेअर बी एक्स वाय झेड रिप्रेझेंट द ऑब्झर्वेशन पॉइंट and x dash 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 represent the coordinates of the source. ठीक है, this is the source point and this is the observation point. Now r is the distance from the source to observation point. ठीक है, so that r is equal to small r वो किया है. dl dash मतलब dz dash, because on the z axis that means length is in z. I current, it is along only z direction, so only I x y z का हुआ I of z dash, and that again I is a total constant current, so it is I0 and az cap. Az cap indicates the direction of the current. It is the unit vector. Here the source is at origin and spherical coordinate r is as shown in the figure. Now the equation 2. This one, ये वाला मॉडिफाई करना है, मतलब हमें पुट करना है म्यू अपॉन 4 पाई कांस्टेंट इंटीग्रेशन माइनस dl by 2 to plus dl by 2, because this is the dl by 2, dl by 2, so integrating from this to this, तो ये जब सॉल्व करेंगे तो ये इक्वेशन आता है a बार के लिए ये वाला. So a bar x y z equal to mu I0 dl 4 pi r e raised to minus j beta r az cap. Now as this is the az cap, this complete is the az, that means this az is the scalar part. Okay, so this complete az is the scalar part. From the above equation, it is clear that if current is in the z direction, the vector magnetic potential is in az cap direction. Obviously, if it is z, unit vector is also az. Right? Now, ये हुआ a, ये जो फाइंड हुआ हमारा a बार. सिंपल 4 स्टेप का एनालिसिस है, बट उसको 4 पेज लगते हैं. ठीक है, एग्जाम में कंप्लीट एनालिसिस नहीं पूछते. एग्जाम में ऐसे पूछेंगे, प्रूव दैट द रेडिएशन रेजिस्टेंस ऑफ इनफाइनाइटेसिमल डायपोल इज 80 पाई स्क्वायर लैम्डा स्क्वायर इज दिस. वो प्रूफ करना है हमें. ठीक है, रेडिएशन रेजिस्टेंस. और सपोज टू फाइंड द with diagram, infinitesimal diagram, through the radiation. Generally the questions are on radiation resistance. Okay, but it is in syllabus. Complete analytical treatment of all these 4 dipoles are given, so any type of question will be there in exam. Okay, we can't predict, but generally as per till question papers of RMT, only the radiation resistance questions are there, or in previous pattern exams directly 18 mark question was there, like a complete full analytical treatment of any suppose half wave dipole antenna. So it is 18 mark question was there, but in I think 2015 pattern 4 the questions are